Okay, now it gets, I was going to say easier, but I don't know, more complicated, but at least you don't have to graph anymore. So this is solving a system of equations through a method rather than just graphing. Earlier it was graphing, now it's, anyway. The two equations they give us are y minus 4x equals negative 1 and y equals 7. 7. I wrote a z. Let me erase that. Okay. Y equals 7. So this is two lines just like before, and we could graph it out. We could make a little graph and graph out the two lines, see where they meet, or we could substitute. This is doing it through the substitution method. So if y equals 7, that means I could take this y and replace it with a 7. Because this equation tells us that y is replaceable with 7. Those two are the same thing. You can flip them and they'll equal each other. So I'm going to rewrite this equation, substituting y for 7. 7 minus 4x equals negative 1 minus 7 minus 7. I'm going to get negative 4x equals negative 8. And then I'm going to divide by negative 4, divide by negative 4. Negative 8 divided by negative 4 is the same as 8 divided by 4, which is to say 2. So x equals 2. And we already know that y equals 7. So 2 comma 7 is our solution. That's where the two lines meet. Alright, here's a second one that we can solve through substitution. We've got negative 3x plus 3y equals 4, negative x plus y equals 6. We're going to isolate either the x or the y so that we have something for it to equal. And since this is a negative, it would be easier to work with something that's already a positive. So we're going to add this x over, and we're going to have y equals 6 plus, that's an x, 6 plus x. Now I can take this phrase, 6 plus x, and substitute it in for y. So I'm going to do that. Negative 3x plus 3 times x plus 6 equals 4. You see how I did that? Where this y was, I substituted the entire phrase x plus 6. Okay. So let's see. 3x plus 18 minus 3x. Uh-oh. That's 0. Equals no solution. It must be no solution. Let me scroll down. Yeah, the system has no solution. Because the 3x canceled out, and we were going to have x equals negative 14, which is untrue. 0 cannot equal negative 14. 0 equals 0. So since that is untrue, the system has no solutions. All right. The next one is negative 4x plus 2y equals 6, and y equals 2x plus 3. Those are our two equations. So I'm going to take this y equals 2x plus 3, take this whole phrase, 2x plus 3, and put it in here. So negative, that's a big old negative. Negative 4x plus 2 times 2x plus 3 equals 6. Okay. So now I'm going to go 2 times 2x is 4x. 2 times 3 is 6. Equals 6. Drop this negative 4x down. Looks like we got another problem where these x's are going to cancel out. Negative 4x plus 4x equals 0. So those go away, and we're left with 6 equals 6. So that's different from the last one, because this is a true statement. 6 equals 6. So if it ends up being a true statement, like 6 equals 6, then it's infinitely many solutions. So you got to work it till the very end to see if it's 0 equals 1, which cannot be true, then it's no solutions. But if it's a number equaling itself, then it's infinitely many solutions.